So let's go ahead and compare electric potential with electric fields, something that we're hopefully familiar with. So electric fields, they tell us for a particular point in space what the force would be per how much charge put at that point. Per coulomb tells us if, for example, a field is 10 newtons per coulomb, you put a coulomb at that point in the field, there'll be a force of 10 newtons on it. Whereas electric potential tells us for that particular point in space what the electric potential energy would be per coulomb put at that point. Electric fields are vectors. Electric potential is a scalar. The equation for electric fields, E is defined as the force per unit charge. Notice the vector signs. Whereas for electric potential, U, or V rather, is defined as U over charge. Volt, U over charge. Remember the mnemonic. So notice no vector signs here, which makes electric potential a lot easier to work with. You can rearrange this equation right here. The force on a particle is the charge of the particle times the field that it's placed in. And in the same way, the potential energy electric of a charge is charge times the potential. F equals QE, UE equals QV. All I did was just rearrange these two equations. The direction here is defined by the direction of force on a positive test charge. So negative charges are forced in the opposite direction as the electric field points. Where this situation is that positive test charges, if released, they will naturally fall to lower potentials, just like a ball rolling on a hill. Positive test charges naturally roll downhill to lower potentials, just like a ball rolls to lower altitudes on a hill. Negative test charges, by contrast, roll uphill to higher potentials. And as long as you remember that, the hill analogy works very, very well. The electric field created by a point charge, or spherical charge, and this is just derived by Coulomb's law, like this. The force is KQ Q naught over R squared. So the electric field produced by charge Q, not Q naught, but Q naught is the test charge. The field's produced by Q, and Q naught is affected by the field. So it's the force on Q naught divided by Q naught. That's KQ Q naught over R squared divided by Q naught. KQ over R squared is the electric field caused by charge Q. Similarly, the electric potential created by a point charge or spherical charge, we can derive it the same way. This is electric potential energy, KQ Q naught over R, and we'll derive that with the C kids for the AP Physics 2 kids. We just give you this straight up. This works for a spherical or a point charge. For the electric potential, U over charge, electric potential energy of the system of Q and Q naught divided by the distance between them, divided by Q naught is just KQ over R. Bottom line, electric potential caused by a point or spherical charge Q is KQ over R, where R is the distance away from this charge Q. And this does assume that the electric potential energy, as well as the electric potential, is 0 at R equals infinity.